Hi there, and welcome to section 4.10. Here in the book, we're going to be talking about the conformations that a cyclohexane can undergo. We'll be focusing a lot on cyclohexanes throughout the rest of this chapter, especially on how the molecule actually looks. So let's focus for now on the two most common ways a cyclohexane can exist in solution, which is either as a chair or in a chair conformation, I should say, where you can imagine that this part I have in blue here is the part where you sit. The part in yellow is where your feet go. And the part in purple there is where your back goes. You might recognize this conformation because I drew it in the end of the last chapter. And if you do remember, then hopefully you also remember that hydrogens go something like this in this conformation. Because that's how we drew it before. And what's kind of cool about the chair conformation is that we can draw a Newman projection of a chair, just like we drew of a single carbon-carbon single bond, except the Newman projection looks pretty differently, because instead of looking at just one bond, now we're going to focus on two bonds here, these two carbons. So we're going to look at it straight on like this. And as we do that, we can draw a Newman projection that looks sort of similar to what we had before, but kind of different. So I'm going to have one drawn in purple there and one drawn in blue. There we go. We'll bring that down here. So coming down here, the one in left is purple and the one on the right is blue. So here's the one on the left and here's the one on the right. Okay. And it looks like in between the purple and blue one, we have the feet part of the chair. It goes down. So we'll draw that like this. And in the back, because remember, these bonds we don't see. In the back, we have the part where our head goes and our back. And that looks like this. Now, I know it kind of looks funny, but you'll have to use your mind's eye to see that those two, that's how this should look. I'll try and give another tutorial presentation soon, like I did for the other Newman projections that we looked at before. So if we draw in the hydrogens as they exist here, we would see that we have one here, here, and here. And there are two hydrogens there and there, and two here and here. So in this Newman projection, you can see that this is what could be called a staggered position, except that we have not also drawn in the other hydrogens from the back carbon, the one that we can't see at the moment. There we are. So now this is like a fully staggered position, and in fact, this is one reason why the cyclohexane chair conformation is so stable, because the Newman projection shows us that there are no eclipsed interactions that we see here, and so the strain torsion is very low. Now let's look at the other stable conformation, the boat conformation. In the boat conformation, we'll draw here, it looks fairly similar, except that we don't have a place to put our feet in the boat. Let's draw that a little differently. There we are. And in the boat conformation, the hydrogens are also placed a little differently in that you have them like here. There we are. That's like the boat conformation. And the boat conformation is also stable, like the chair conformation is, but it's a little less stable. And the reason why goes towards, or the reason why it's less stable can be seen from its Newman projection. So let's focus on once again, that carbon and this one. And using our eye here, let's have a look at these two. Okay. So looking at the Newman projection of these two, the purple was on the left, and the blue was on the right. Now we have both going up, okay? So if we have both the front and the back going up like this, and then we draw in our hydrogens here, here, then it turns out that the other hydrogens that we're looking at have a pretty eclipsed conformation here, unfortunately. And to go along with that, what makes it even a little less stable than the cyclohexane is that these two hydrogens also have kind of a torsional strain interaction, except it's a special one. So we'll circle that in yellow, and we will write in, it's called a flagpole interaction, because those two hydrogens are sort of jousting with each other at the top of the boat there. So your book goes into a little more detail about how the boat can be kind of twisted into what's called a twist boat to alleviate some of that strain. But I think what's more important is that now that we've seen both conformations and the Newman projections, that we look at an energy diagram for each conformation. This is also present in your book, in case you're wondering, in figure 4.2. So if we start in the most stable conformation, which I said was chair, and we start to change how the molecule, oops, let's put that in blue, how the molecule wants to be from chair all the way to boat. Well, first we have to move the part where our feet go, the purple part, right? We need to move that up to become the other half of the boat. Well, to do that, we can't just go straight up. It turns out that we need to instead go into what's called half chair. And that's where you kind of kick the footrest up, but it stays in a horizontal position. And that actually has a very high energy level barrier because there are many more torsional strain interactions in the half chair. So after you get to the half chair, then you relieve a lot of strain by making what's called a twist boat, where now something like that with a much lower energy. And then finally, you can get up to the next most stable conformation in kind of the middle ground, which is our good friend, the boat. And if you were to make like a little trace map of this, it would look something like this. And of course, you could flip down the other side to make a chair going the other way, kind of bringing that one down and following the same progression. And again, that figures in 4.2 or 4.20, sorry. So this is how the conformation energy diagram would look for cyclohexane. And we just talked about how it could exist either in a chair or in a boat. So this has been section 4.10.